Hi everybody, in this video we are going to be working on finding the areas of triangles using things that we've already learned in this section, the law of sines, law of cosines, and also something new, a formula called Heron's formula. So we'll be working on both of those things in this video. Okay, so in the past we've been doing, or you guys have been doing area of triangles for years. We probably started back in elementary school learning that the area of a triangle, the formula for that is that the area equals 1/2 the base times the height. So we're going to work with that, but now build from it. So if you look above, we have a triangle that we actually don't know the height. And here's where it's going to be a little bit different. Up to this point, you either were given a right triangle or we're given a triangle like in this picture where the height is present. But now we're not going to know the height, and it's not going to be a side that we can solve for, or length that we can solve for um, in ways that we've done in the past. Now what we're going to have to use is our knowledge of trigonometry to be able to find that height. So if we look here to angle C, and we consider how H is related to angle C. So think about trig here. We're going to know probably side A. Side A in this smaller red triangle is actually our hypotenuse. And in this smaller red triangle, the H side is our opposite. So the trig function that relates those two sides is going to be the sine function. So the sine of angle C is going to be equal to the opposite, which is H, over the hypotenuse, which is A. So we can fill that in down here. We know that sine of C is H over A. Now we didn't use B because B is the entire length of that side of the triangle. So we had to use the smaller red triangle because we know that we have A. We could have gone over to the left and used this smaller green triangle and related angle A and then used side C. But it's going to make the formula by going with the side we went on. It's going to make it nice and easy to remember. So if we rearrange this, if we're trying to solve for H, we're going to multiply both sides by A, which tells us that H is equal to A times the sine of C. Okay, so now we're going to put this all together. Over in the original equation, we said the area is 1/2 the base times the height. We're going to now substitute H in for H. So this whole formula is going to come over here and go in for H. And I'm going to rearrange it so that I can fill it in this box in the way that's going to be easiest to remember. So what we're going to now know is that the area is 1/2. We've got an A, we've got B from the original, and then it's multiplied times sine of C. So in case you want to see that out, we've got area equals 1/2 B times A sine of C. Multiplication says we can just rearrange, so it's easiest just to remember in alphabetical order that area equals 1/2 AB sine of C. So to use this formula, 1/2 equals AB sine of C, we have to have the triangle set up in the side angle side progression because pretend that this is side A in problem number 1. That would mean that this is side B, side C is across, and therefore this is angle C. So we've got two sides next to each other, and then we've got that angle measurement that's in between. So that's when we're able to use this formula. So all we have to do is have our formula and plug it in. So area equals 1/2 AB sine C. So we've got area equals 1/2 16 times 11 times the sine of 105 degrees. Plug that in your calculator and you're going to find that the area equals 85, in this case, feet squared. So if that feels good to you, go ahead and pause this video. Give number 2 a try. I'm going to keep going through and explain that out as well. So same idea. I like to label my sides first, label my angles. I just find it easier to keep it all organized. So again, area equals 1/2 AB sine of C. So area equals 1/2. A is, in this case, 25. B is 21. Sine of 24 degrees Put that in your calculator, push enter, and we're going to get 106.77 inches squared. And that is using trigonometry to find the angle of a triangle. So sometimes when you're doing these area problems, you're not actually going to have the information that you need to be able to solve the problem, but we can find it. So this is one of those, if you look, we have two angles, but only one side. We said in questions 1 and 2, and based on the formula, we actually need two sides and the angle that's in between to be able to find the area of the triangle. So we've got to do a little problem solving first. I'm going to go and I'm going to label this triangle. So we're going to call this top angle 76. That's going to be A. I'm going to label B as 59, and then C is this unknown. So we don't yet know what that third angle is, but we know that the interior measurement of a triangle is 180 degrees. So if we subtract 76 and 59, add those together and subtract it from 180, we're going to find that angle C is 45 degrees. So now we have one piece of the information. What we're going to do now is solve for a side. We have to have two sides. So I'm going to solve for side AC, and I'm going to call that side X. We're going to solve for the length of X. So now, if I go through and I kind of plot out the information I have, 76 goes with 7, and X goes with 59. Those are the sides and angles that are across from one another, which allows me to put them into the law of sines formula. So I'm looking for X. I'm going to have that start on top. I'm going to say X over the sine of 59 degrees equals 7 over the sine of 76 degrees. So again, you could put these as the sine of 59 degrees over X and the sine of 76 degrees over 7. As long as you have the sides and the angles in the same relative place in the fractions, either way, this is just easier because we're trying to solve for that X value. So I can get it alone by doing one step by multiplying both sides by the sine of 59 degrees, leaving me with X is equal to 7 sine of 59 degrees divided by the sine of 76 degrees. When I put that through in my calculator, I'm going to find that X is equal to 6.18 millimeters. So I'm going to fill that in up here, 6.18 millimeters. So now I actually have everything that I need. I have an angle measurement, and I have two sides that the two sides that actually create that angle. So now I can use my angle formula to solve for the area of this triangle. I've got that the area is 1/2, A in this case is 7, B is 6.18, sine of C, which is 45 degrees. Put that in your calculator, hit enter. We've got that the area is 15.29 millimeters squared. So again, the formula itself for the area of the triangle is using our trig function. So that kind of adds that layer to finding the area of a triangle. But we're also going to be using the law of sines and the law of cosines to fill in information that we might be missing in order to find the area. So consider these problems as that we're putting it all together as you move forward. So again, in number 4, we have two angles and one side measurement. So we know right away we're going to have to find another side. So I'm just going to go ahead and label it this triangle so that I can be consistent. So I've got A here, B here, and C here at 126 degrees. You can label this however you want. That's just how I'm doing it. Second step is that I'm going to actually find angle B, because it's angle B that's across from this 13-kilometer side. So that's my pair that goes together that I'm going to need to use to find the other side. So I'm going to take 180, subtract 126, subtract 22, and I'm going to find that angle B is equal to 32 degrees. Now that I have that, I have my ratio. I am going to solve for length BC, and I'm going to again call that X. So to set up my law of sines, I'm going to say that X is the side I'm looking for, goes with 22 degrees. So it's X over the sine of 22 degrees equals, and then I'm going to use the sides that I have, the side that goes with the angle measurement. So that's 13 goes with the sine of 32 degrees. I'm going to go through to get x by itself, multiply both sides by the sine of 22, leaving me with that x is equal to 13 sine of 22 degrees over the sine of 32 degrees. You can put that in your calculator, and you're going to find that side x is 9.19 kilometers. So now I have everything that I need. I'm going to write that the area is equal to 1/2. Side A is that 9.19. Side B is 13 times the sine of C, which is the sine of 126 degrees. Again, put that in your calculator, hit enter. We're going to find that the area is equal to 48.33 kilometers squared. So number 5 is a little bit different. Here, instead of having two angles on one side, we have two sides and one angle. Again, we're going to be using the law of sines to try to figure out the missing angle, but we have to remember, back to law of sines, think way back, when we find an angle using the law of sines, we occasionally have an extra angle that we don't solve for right away. When we use our calculator to find a sine value or find an angle with a given sine value, we're only finding the answer in quadrant 1. But we said that sine values, the same sine value, can happen for an angle in quadrant 1 as well as an angle in quadrant 2. I gave you this little graphic that here's our unit circle, that if we have an a y value that's happening in quadrant 1, that same value can also happen in quadrant 2. So not only do we have this angle that we might need to find, or that we do end up finding, but we're also going to have this angle that has that same sine value. So we're going to have to keep that into consideration when we're using the law of sines, that there might be two answers, and we have to make sure that we're finding the ones that make sense, whether it's one answer or multiple. So keep that in mind going forward. But let's see what we can figure out here. So right from the start, we've got that 85 goes with 11. Those are the angle and side that match up across from one another. So this 5 side length is going to be across from this angle here. I always like to name my sides and my angles first. So I'm going to call this 85 degrees my angle A. I'm going to find the one that I'm missing over here is angle B, and angle C is at the top. So I'm going to use the law of sines to try to find that angle B. So the sine of B goes with 5, that goes over 5, equals the sine of 85 degrees over 11. So I'm going to get the sine of B by itself by multiplying both sides by 5. So the sine of B equals 5 sine of 85 degrees divided by 11. Now remember, I want you guys to go through and actually solve this, because that number has to be between -1 and 1. So when you do that in your calculator, you're going to find that 5 times the sine of 85 divided by 11 is 0.4528, which is within that range of sine. So we can find the inverse sine. We're going to say that B is equal to the inverse sine of 0.4528. So this is saying B is the angle whose sine is 0.4528. What we're going to find there is that B is equal to 26.92 degrees in quadrant 1. But remember, this value, 0.4528, I'm going to go back to my little drawing of the unit circle, happens here in quadrant 1, but it also happens here in quadrant 2. So to find that value, I'm going to subtract the 26.92, that's my reference angle here. I'm going to subtract it from 180 to get that second terminal side in quadrant 2. So 180 minus 26.92 gives me 153.08 degrees. So now I have to check which angle makes sense, one or both. So we're starting with 85 degrees is our given. That's the one angle that we do know. If I add 26.92 to 85, those two angles together are less than 180, so that angle works. However, if I add 153.08 to the given angle of 85, that is going to be greater than 180. So that angle does not work. That 153.08 is not viable. The only angle we have to worry about or have to deal with is the 26.92. So that is in fact the measure of angle B, 26.92 degrees. So now I can solve for angle C, which is actually the angle that I need, because remember, I need the angle that's in between the two sides. I've got side A here, I've got side B here. I need that sine of C. So I'm just going to subtract 85 and 26.92 from 180, giving me that angle C is 68.1 degrees. So to find my area equals 1/2. Side A we said was 11. Side B is 5 times the sine of 68.1 degrees. When I go ahead and put that in my calculator, I'm going to find that A, the area of the triangle, is 25.52 centimeters squared. Question number 6 gives us a slightly different view again. Now we don't have any angles given. All we have are the 3 different side lengths of the triangle. So we're going to have to use, in this case, the law of cosines to be able to find the angles that we need, or one of the angles. So what I would recommend is to always have the angle that you're looking for be across from the biggest side. It ends up working out the best. So 16 yards is my longest side. So I'm going to have the angle that's across from it be angle C. We use the equation A equals 1/2 AB sine C. So I'm going to just make that my angle C right away. I want to find the biggest angle. From there, it doesn't matter. I'm going to call this A and I'm going to call this angle B, making my 6-yard side B and my 14-yard side A. So again, we are looking specifically for angle C. So to use our law of cosines, we're going to use the C squared formula. So C squared equals A squared plus B squared minus 2AB cosine of C. We just plug in our values. So 16 squared equals 14 squared plus 6 squared minus 2 times 14 times 6 times the cosine of C. I'm going to square everything out and combine things together. So 16 squared gives me 256 equals 196 plus 36 minus 168, if I multiply all those through, cosine of C. I'm going to get cosine of C by itself, so I'm going to add these two together and subtract from 256, leaving me with that 24 equals negative 168 times the cosine of C. Divide both sides by negative 168, finding that the cosine of C is equal to negative 0.1429. Now, it's totally fine that the cosine is negative, because if we think back to our unit circle, cosine is actually negative in quadrant 2. So it's going to have a positive y value, but a negative, remember cosine goes with x, a negative cosine value. So that's totally fine. To find the measure of angle C, you're going to take the inverse cosine of negative, make sure you do put that in, 1429. Therefore, C is equal to 98.2 degrees. I'll fill that in up here too. So now we have two sides and the angle in between, so we can go ahead and find the area of this triangle. Area is equal to 1/2. Side A is 14. Side B is 6 times the sine of 98.2 degrees. Put that in your calculator, hit enter. We're going to find that the area is 41.57 square yards. That last problem brings us into Heron's formula. So when you're given all 3 sides, just like we did in the last one, you can use the law of cosines to find one of the angles and then use the area formula. But there's actually kind of a shortcut as well. So when you're given all 3 sides of a triangle, you can use this formula I'm going to give you here. It's that the area is equal to the square root of s times s minus a times s minus b times s minus c. Now that s variable is something new. S stands for the semi-perimeter, or the perimeter divided by 2. So all we have to do to find that is multiply the sum of the sides times 1/2. So again, perimeter is adding up all the sides. Semi-perimeter is all of the sides added together, the actual perimeter divided by 2. So just so you have that for your notes, this is the semi-perimeter. So all you have to do is add together, find the perimeter divided by 2, and then use that S value, plugging it into this area formula. And you're going to multiply the semi-perimeter times the difference of the semi-perimeter and each of the sides. So I will show you what that looks like in an example. Here's our triangle with all 3 sides given. Now remember, we could go through and use the law of cosines, find one of the angles, and then use our normal area formula that we learned at the start of this video. But here's the shortcut using Heron's formula. So the first thing we have to find is that semi-perimeter. So the semi-perimeter is 1/2 the perimeter, the sum of all the sides. So that would be 18 plus 21 plus 19. If I add all those together and divide by 2, I'm going to find that this S value, my semi-perimeter, is equal to 29. Now I'm going to use that in Heron's formula. So Heron's formula says that the area is the square root of S times S minus A times S minus B times S minus C. So area equals. Now in this case, it doesn't matter which side is which. You can label them if you want, or you can just say we're going to subtract each of the sides from S, either way. So it's going to give me 29 out front for the first S times 29 minus 18 times 29 minus 21 times 29 minus 19. So area is equal to the square root of 29 times 11 times 8 times 10. This is where I'd put it in your calculator. When you find all those through, you're going to find that the area is equal to the square root of 25,520. I'm not asking you to rationalize this or reduce the square root. You can actually just put it in your calculator. So the area is going to be equal to 159.75 miles squared. And that's how to find the area when you have all 3 sides and can use Heron's formula. The last problem is an application problem. So again, we're going to be drawing our triangle instead of being given what it looks like. So question 8 says that a triangular shaped piece of glass has side lengths that measure 35 inches, 27 inches, and 14 inches. We're supposed to find the area of the glass to the nearest tenth of a square inch. So I'm just going to sketch it out. I always like to see it. In this case, it doesn't make a big difference, but I like to be able to see that triangle. So we've got 35, we've got 27, and we've got 14. First thing we do is find that semi-perimeter. So 1/2 of 35 plus 27 plus 14. Semi-perimeter is equal to 38 when we do all that through. Now we can use Heron's formula. So area equals the square root of 38 times 38 minus 35 times 38 minus 27 times 38 minus 14. The area is equal to, you can skip all these steps and put it right in your calculator if you want to. I'm just going to show out where it comes from. 38 times 3 times 11 times 24. So that is equal to the square root of 30,096. So the area is equal to 173.5 inches squared. And that is area of triangles using both law of sine, law of cosines, and Heron's formula. Let me know if you have any questions.